Okay, so let's talk about ions and ionic bonding. Now let's do ions first. Let's talk about how ions are formed. So anything in group 1, these guys all end in S1. That means they have one valence electron they want to get rid of. And if you lose a valence electron, if you lose an electron, you end up with more positive protons than negative electrons, so you end up with a +1 charge. These guys, S2, they have two valence electrons they want to get rid of. They're going to make a +2 charge. And over here, these guys have S2P1. They have three valence electrons, and they want to get rid of all three, and they make a +3 charge. Now carbon, these guys are going to share, but then we start with nitrogen. Nitrogen's got S2P3. That's 5 valence electrons. If you have 5, you want to get 3 more, so they're going to gain 3. Oxygen has got S2, anything in that group, 6, P4. The 2 and the 4 is 6, and that means you're going to gain 2 electrons. And finally, these guys end in S2, P5. So they have 7 valence electrons. That means they're going to gain 1. And the last group, they all end in S2, P6, except for little helium, which is just S2. But either way, they have 8 valence electrons, or the 2, and they're filled, so they don't want to make any charge. So they're happy on their own. They don't want to bond with anybody. Okay, so now let's take a look at the questions that you're asked. Number A, or letter A, says, any group 1 element, what are they going to do to become stable? They're going to all lose 1. So if you're in group 1, you lose. Anything with 6 valence electrons, if you have 6, you need 2 more to get to 8, so you're going to gain 2 electrons. You end up with a -2 charge. Over here, by the way, you guys are going to become a +1. If you're got 1 valence electron and you want to lose 1, then you end up with a +1 charge. Nitrogen and phosphorus. These guys are in group 5, so that means they have 5 valence electrons. They have the S2P3, and they need 3 more to make it P6. So they're going to gain 3 more negatives, so they're going to have -3. And this is the exact same thing. I'm sorry, this is not the exact same thing. If you have 3 valence electrons, if you have S2P1, P1, then you have 3. No one's going to give you 5. That's unheard of. So instead, you're going to kick out 3. So if you have equal numbers of positives and negatives, and you lose negatives like that, you lose 3, then you're going to end up with more positives, so you have +3 charge. Iron 2, Roman numeral tells you it's going to lose 2 electrons, and it's going to give you a +2 charge. And an element whose configuration ends in 5, 4, 5. What's your highest energy level? 5. So you're going to add up anything in the S's and the P's in the 5th energy level. So S2P5 equals 7 valence electrons. You're almost there. You want 1 more negative, so it's going to be -1. Okay. Other things you should know, some vocab here. Cations, you should know that little T in the middle resembles the T in the middle of the word metal. It also looks like a plus sign. So cations are metals, and they're positive because they have equal numbers of positives and negatives, and then they lose electrons, and they end up with more positives. So these guys are positive charged because they lose electrons. Over here, anions got 2 ends. One's for negative, one's for nonmetal. They started off equal, and then they ended up gaining electrons, which means they're going to have more negatives. So these guys have a negative charge because they gain electrons. -1, -2, and -3. These guys, by the way, can make +1, +2, or +3. Okay, so number 3. It says, when are parentheses used in writing formulas for ionic compounds, and then why are Roman numerals? So parentheses are used anytime you have a polyatomic ion, and anytime you have more than one of them. So let's say you have magnesium, +2, hooking up with hydroxide, -1. You put the 2 down here, and you put the imaginary 1 there, and you end up with MgOH2. Now, if you left it like that without the parentheses, you would have 1 magnesium, 1 oxygen, and 2 hydrogens. And that's not what we want to imply. We want to imply that there's 2 sets of hydroxide, so we put parentheses around it. For instance, if I was doing ammonium hooking up with phosphorus, or phosphate, rather. Let's do that. Phosphate. So we take the 1, put it after the phosphorus, take the 3, put it after here, and we would end up with NH43. That doesn't make much sense. So we'd rewrite this NH4 in parentheses, and we want 3 sets of that. And we don't put parentheses around this because we only want 1 set of it. So don't go parentheses happy. Only put them around stuff that you need more than 1 of. Now, Roman numerals, these are helpful because some ions, such as copper makes +1, or copper makes +2 charge. So in order to differentiate, like let's say copper is bonding with oxygen, if here's, well, I did them backwards, but if here's copper +2, oxygen -2, that's that formula. And if copper was a +1, and oxygen still -2, crisscrossing, you end up with C2O. Now, if I called both of these copper oxide, I'd have an issue because they're two different formulas, so I have to differentiate between them. So I'm going to put the Roman numeral, so this one is going to be copper 2 oxide. I know there's only one in the formula, but it's copper 2 because that's the charge, +2. And this one, there's 2 in the formula, but that doesn't matter. All I want to do here is put the Roman numeral for the charge. So this tells you copper is a +1 charge to make this substance right there. Okay? So Roman numerals for ions, usually they're in the D block or low P, way down low in the P block. Those are the ones that you're going to have to check to see if they make more than one charge, and we're going to give you a reference sheet to help you out with that. Okay, let's tackle this table here. All right, we got sodium and sulfur. Sodium is in group 1, so it's +1. Sulfur is in group 6, so it's going to make a -2. One sulfur is not good enough to make one sodium is not good enough to make one sulfur happy, so we're going to have to crisscross the charges, and it's going to be Na2S, so that means there's a 2-to-1 ratio. We need 2 sodiums to make one sulfur happy. Potassium is now hooking up with sulfate. Notice sulfate versus sulfur. This is SO4 -2. So you're going to end up again with a 2-to-1 ratio because potassium can only give up 1, but sulfate needs 2, so it's going to be K2SO4. The name potassium sulfate, the one above it was sodium sulfide. Remember, right off the periodic table, if it's just S, it's sulfide. If it's got the oxygen bonded to it, it's 8. Aluminum. Now we got aluminum hooking up with nitrogen, and then aluminum hooking up with nitrate. So aluminum always makes +3. That doesn't change. But we've got nitrogen off the periodic table, and we've got nitrate, which should be in your brain by now. So these guys are going to make a 1-to-1 ratio because aluminum's given up 3. And nitride, is saying, I want 3, so that's perfect. It's ALN. This is a little bit different story. Aluminum's trying to give up 3. Nitrate is saying, I can only take 1, but I'll go find some friends. So it's going to be a 1-to-3 ratio, and it's AlNO3. Notice I put it in parentheses, 3, because we want 3 sets of a polyatomic ion. Now the next one, iron +3. I love it when I see Roman numerals because that tells me I don't need to think about the charge. Iron is in the D block, so I'd have to look it up, but the Roman numeral gives it away. It's +3. Oxygen always makes a -2. I'm going to crisscross them, and it's going to be a 2-to-3 ratio, Fe2O3, and that's iron 3 oxide. Notice there's only 2 in the formula. That doesn't tell you what the charge is. The charge is equal to the Roman numeral here. Calcium, group 2, +2. Phosphorus, group 5, so it gains 3. This is going to be a 3-to-2 ratio when you crisscross them. So we're going to have Ca3P2. Take the 3, put it there, take the 2, put it there. Now notice that was phosphorus, not phosphate, so it's just plain old P. Alright, we got gallium underneath aluminum, so it makes +3. Carbonate is -2. Crisscross them, and it's going to be a 2-to-3 ratio, and it's Ga2CO3, which is carbonate. 3 sets of them, so we put carbonate in parentheses. Strontium, +2, I believe. Hydroxides, OH -1. Crisscross them, it's going to be a 1-to-2 ratio, SrOH2. And magnesium, Mg+2. Phosphate, 8. So it's P with oxygen bonded to it. Hopefully you memorize them and know how many. 3-to-2 ratio, because when you crisscross them, it's Mg3 and then PO4, 2. We want 2 sets of that, so we put it in parentheses. And that's it. So check for Roman numerals, check for your polyatomics, make sure you know the difference between ides and eights.